Hello everyone. So, in the lecture series of cognitive ergonomics, we come to lecture number 4, human cognitive abilities and skill. We will start this lecture with the multi-store memory model. This multi-store memory model is also known as information processing model. The model proposed by Richard Atkinson and Richard Schifrin in 1967. We saw the form of its model in our previous lecture, where we tried to address the attentional resources, decision making, long term memory, working memory involvement, perceptual processes, and then a feedback loop which is connected again to the sensory register. This model is the similar model which we saw earlier. However, this model explains the stages of memory. There are 3 stages of memory which help us to register information for the future reference. How does this model work? From the environment, we select the sensory stimuli. The stimuli our sensory register collects. The nature of the sensory stimuli could be visual, auditory, tactile, olfactory, etc. Once we select this stimuli, it moves into our sensory memory. The literature of human factor or the cognitive ergonomics has paid more attention towards the visual sensory memory and auditory sensory memory. The other type of sensory system or sensory memories have been paid less attention to. There is no biasness in this selection of this sensory information. However, it is easier to process such information and to address such information in a lab setting. That is why auditory sensory system and visual system has been paid more attention to. Once the sensory system has collected the information, upon paying attention to that information, it moves to the short term memory. The nature of visual sensory memory is very brief, less than a second. The nature of auditory sensory memory may go up to 2 seconds. The visual sensory memory, we refer it to as iconic memory, and the auditory sensory memory we refer as echoic memory. Now, once we pay attention to any of these sensory information, it moves into a short term memory for a brief period of time. This short term memory duration is less than 20 seconds. But recent literature suggests that upon rehearsal, upon repetition, upon recalling this information, it may extend up to 30 minutes to 3 to 4 hours. Now, once the short term memory is being formed, the information stays in the system for a period of time. To move this information into your long term memory, we need a sleep. The information gets encoded and stored for a long duration of time for indefinite period of period. For indefinite period of time means the information remains in the system. It may stay there in the system for weeks, for months, for years, for decades, and for century if you live. Now, the information which we do not pay attention to, we forget. The information which is not required, we forget. And this forgetting happens at each and every stages of memory. Because there are 3 stages of memory involved, we call it as multi-store model. At each level, there is a storage happening. And these storage are distinct from each other based on capacity and duration of memory. Once the memory is formed, then it gets consolidated and it remains there in our system. But very soon researchers realized that short-term memory may not be a sufficient condition for the storage, and short-term memory seems to be very passive in nature. Hence, researchers came up with an idea of working memory, a memory which is more active in nature, a memory where the information is getting manipulated, a memory which involves the integration of different sensory information so that the user can make a decision. So, working memory is defined as limited capacity system for temporary storage and manipulation of information. For the complex tasks such as reading, learning, reasoning, comprehension, where integration of information, the complexity of sentences, the integration of words together plays a major role and requires higher cognitive level. Now, what we see in working memory is that it is very distinct from what psychologists were being referring it as short-term memory. This working memory has two characteristics. One is we manipulate information, which was not happening in the short-term memory, and secondly, the number of components. When we are talking about the components, let us see the components involved in working memory. First component is the central executive system. Second is the episodic buffer. Third is the phonological loop. And fourth is the visual spatial sketchpad, VSSP. Now, this model was being proposed by Baddeley and Hitch in 1975. When they proposed this model, that time it had three components in it. The first component which they proposed was central executive system. The second component was phonological loop, and the third component was visual spatial sketchpad. But after 25 years later, when they had chance to modify this model, they added a component there, episodic buffer. They believed that central executive system is not processing all information which central system is receiving from the phonological loop or the visual spatial sketchpad. It is not processing all information, and even a manipulation is happening there, and even a preference is there. But who is deciding this preference? That is what they added after 25 years later, that this is nothing but a episodic buffer. This episodic buffer is actually filtering the information. It is filtering the information. It is acting like a filter. Once the information is being filtered out, then the integration is happening at central executive system. Now, let us see these different stages and levels in detail. This episodic buffer, as I said earlier, the visual memory, visual sensory memory or auditory sensory memory were given preference, but there are other type of sensory system as well, which also reaches the level of episodic buffer, and then episodic buffer decides which information need to be passed on. Let us talk about the phonological loop. The word itself indicate the phone, the sound. But what is this system altogether? Phonological loop is having two components in it. One is the passive phonological process, where the individual is not doing anything, and another is the articulatory process, where the user or the participant or individual is producing a speech. In the production of a speech, sound plays a major role, meaning plays a major role. So phoneme, the smallest unit of sound, morpheme, the smallest unit of meaningful sound, are playing together major role. They play major role in the production. Then another is the phonological similarity, when the two sounds are similar to each other. But similarity is also about the articulation similarity is there, or the sound similarity. For instance, phonological similarity, if you see fi, he, ni, li, me and she, they sound similar. Unlike the words like be, ho, it, odd, shy and up. So there is an acoustic similarity and then articulation, production. So articulatory similarity is there. One is acoustic similarity, another is articulatory similarity. Phonological loop is ensuring the difference between the two sound. Phonological loop is even prioritizing which sound should be paid more attention to. The negative word is given more preference, the negative sound is given more preference than the positive sound. The threat sound will be given more preference to the non-threat sound. The negative words like blood, knife, gun, tiger, lion, all these words are negative and arousing. They may have preference over the positive words or the neutral words like kettle, cup, mug, pen, pencil, rubber. Then another thing, another factor in phonological loop is the word length effect. The length of the word span, number of words recalled immediately in the correct order. Short words have preference over the long words. People can remember easily the short words. Even the rare words versus non-word. Rare words also have preference. So the moment you hear a rare word, phonological loop sends this information directly to the buffer. Let us talk about Visual Spatial Sketchpad. What is it doing? It is also a temporary storage, manipulation of visual pattern and a spatial pattern. What are these patterns? If a grandmaster of chess is there, he or she may be having several visual templates about one single move, which he or she can manipulate to win a game. This Visual Spatial Sketchpad also pays more attention towards the what system, remembering what it is. And then localization, where is it? So visual processing, what is it? And then localizing it, spatial information, where in the space this exists. In the famous experiment by Ungleider and Michigan, where the action pathway and visual pathway was there. So spatial processing. What we have observed, what researchers have observed, Visual Spatial Sketchpad is useful in everyday life. from preparing a coffee till you finish your coffee. Even there are small units, small information in visual form like color, shape, size, texture exist, which we call it as visual cache. More than that, in a scribe, which talks about the spatial and movement information, visual information which is spatially moving in the environment, in the context. It also involves the visual cache and transfer of visual cache to the central executive system. But the transference is not so easy. Any information from phonological loop or visual spatial sketchpad cannot directly move to the central executive system. It is used to select the nature of information. Who is deciding which information should go to the central executive system? Episodic buffer decides that. It ensures if auditory information should go or visual information should go, or any other type of sensory information should go. Episodic buffer was not being added before when Baddeley and Hitch proposed this model. When they proposed this model, only 3 components were there. Later on, they realized that in human factor, the trend is changing. People cannot process so much information. So there must be an inhibition. There must be a system where people are prioritizing or giving a preference to. And this system was the episodic buffer, which they added after 25 years later. It prioritizes the incoming information. It can parallelly pass the sensory information. So 2 sensory information can parallelly pass towards the central executive system, where the integration can happen. It also involves the multimodality processing, because 2 different modalities are there. One is visual spatial sketchpad, another is phonological loop. One is preferring visual information, another is preferring auditory information. 2 different modalities are merging together. So once the information from visual spatial sketchpad and phonological loop passes through the buffer, buffer ensures it if the early selection has to be made or late selection has to be made. Early selection of auditory or late selection of auditory. Early selection of visual or late selection of visual. It reaches to the central executive system, which resembles the attentional system. The attentional system which selects the information. The attentional system which divides the attention. The attentional system which sustains the attention. Selection, sustaining, division, all these are characteristics of attention. So central executive system resembles that. Baddeley identified the 4 executive processes in 1996. And why we are discussing this? To provide you an information that why the central executive system is similar like an attentional system, because people focuses, there is a concentration, you focus attention when you have to execute a task. You divide your attention between the 2 stimuli. 2 auditory stimuli are there. You are making a selection between the 2. Your brother is talking, your father is talking. You divide your attention. Your brother is talking, your stranger is talking. You divide your attention. 2 known people are talking, father and brother. You switch attention between the 2. And then you also interface it with long-term memory. because you need to have information. So there is always an interfacing with the long-term memory. Long-term memory continuously provide you support and help, and central executive system is directly interfacing with the long-term memory. But another researcher thought the system in a very different way. Miyake and colleagues in 2000 reported that instead of 4 executive system which Badley has proposed, we are having 3 executive processes. One is the inhibition, blockage. But this inhibition is no different than selection of information. Like the attentional system is selective in nature. So here you use the system to override the dominant responses. It's troop task. Second is the shifting function. You shift your attention. So you are shifting functions. Cognitive flexibility. How flexible you are cognitively. How can we test this? We can test this using a mathematical problem where we do sometimes addition, subtraction, multiplication and division. And finally, the updating the function, which uses to monitor and engage in rapid addition or deletion of working memory component. So Miyake said that one hand we are inhibiting the system, another hand we are talking about the flexibility. Central executive system is inhibiting some information over the others, and then it is also shifting this, that one task is completed, sound has been processed, now let us move to visual information, or within visual system information I have solved the problem of orientation, now the problem of form or shape or color need to be addressed, and then finally we update that function. To conclude, what we learned with the multi-store model, that there are 3 stages involved in the multi-store model. These 3 stages of multi-store model involves the sensory memory, short-term memory and long-term memory. The information which we do not process, we forget. But in human factor design or in cognitive ergonomics, we do not talk about the short-term memory, we talk about the working memory. The reason being, short-term memory has one component, doesn't manipulate the information. Only rehearsal is there, list of words are there, remembering the list of words, non-words, pseudo words, and then the recall is there. But memory is a complex process. Human factor is a complex task. It involves 4 components. What are these 4 components? Visual spatial sketchpad, phonological loop, episodic buffer, central executive system. Working memory is highly used in human factor and ergonomics. And that is why in ergonomics we talk about working memory, not the short-term memory, unlike in psychology where multi-store model talks about the short-term memory. Visual spatial sketchpad deals with wide range of visual information processing. Phonological loop deals with wide variety of auditory information where segregation is required, discrimination between 2 sounds are required. Not every time we make an absolute judgment, but at each and every level discrimination is part of life. Different type of sensory system is there, we do discrimination. It is always important for a person to distinguish the sounds between police siren, fire brigade and the ambulance, which ultimately leads towards the action which we are going to perform. The moment we see these 3 siren vehicles, we give a passage to them. Central executive system does the integration of all these information. Which information need to be integrated first? It integrates first. It does an early selection and it also does a late selection. Finally, buffer seems to play a significant role here in the selection of information. Buffer seems to play a significant role here in deciding which information should be passed on. So, buffer is playing a decisive role here in the working memory processing. Well, it is important to note here, different individuals may have different threshold of these processing levels. One may be good with VSSP, another may be good with episodic buffer, another may be good with phonological loop, another may be good with central executive processing, and another may be good with all four components together, and one may be failing to reach the optimal level in all these processing levels. In the next lecture, we are going to talk about the working memory capacity and its duration. Thank you.